Today, the gas laws. Already you all have done Boyle's law and Charles' law in class 9. Now we'll do Gay-Lussac's law of combining volumes. So what does Gay-Lussac's law of combining volumes states? When gases react, they do so in volumes bearing a simple ratio to one another. Suppose hydrogen and chlorine is reacting, so they will bear a simple ratio. 1:1. Here we can see that it is 1:1. One volume of hydrogen reacting with one volume of chlorine. So they bear a simple ratio to one another and to the volume of the gaseous product. If the product is gaseous, then it will be in a simple ratio with these two. Remember, this is applicable only to gaseous state of matter. Liquid, if the product is liquid, then it will not apply to that. So the gaseous product, provided all the volumes are measured at the same temperature and pressure. Temperature and pressure should be same. So let us take examples like, say, formation of hydrogen chloride over here. So what is the ratio? 1 unit of hydrogen is reacting with 1 unit of chlorine and forming what? 2 volumes of HCl. 1 volume, 2 volume. What is the ratio? 1:1:2. Again, suppose ammonia, Haber's process, ammonia. Nitrogen reacts with 3 volumes of hydrogen to form 2 volumes of ammonia. So what is the simple ratio? 1:3:2. Or the formation of water. Two volumes of hydrogen is to 1 volume of oxygen, forming 2 volumes of water. Now remember, the water is not in a liquid state. Water is in the form of water vapor or steam. So we write a G beside, just to say that it is the gaseous state of water. So in all these examples, we have seen that the reactants are gaseous, the product is also gaseous, and they bear a simple, the reactants bear a simple ratio to each other as well as the product. If the product is gaseous, that will also bear a simple ratio to the reactants. Now let's do some examples, some numericals, then it will be clear. Leave these two. If 6 liters of hydrogen and 4 liters of chlorine are mixed and exploded, what will be the composition of the resulting mixture? Reaction will always be given to you, but always check whether the reaction is balanced. Should be a balanced reaction. So first thing we do is check the balanced reaction. Is it balanced? It is balanced. So now we will move in. Then next is we find out the limiting factor. Which is the limiting factor in this? Means which is in less amount over here. Hydrogen, chlorine. Chlorine 1:1. What is the ratio? 1:1. 1 volume of chlorine is reacting with 1 volume of hydrogen to form 2 volumes of HCl. So limiting factor is this 4 liters of chlorine. So 4 liters of chlorine means 1:4, and here this is also 1:4. This will be 2:4. The ratio is 1:1:2. So we have to multiply each with 4 since we have a limiting factor, that chlorine, 4 liters. So 4 liters of chlorine will react with 4 liters of hydrogen to give 8 liters of HCl. Now if 4 liters of what is asked over here, what will be the composition of the resulting mixture? So the resulting mixture, we find that what is formed after the formation, it is after the reaction has taken place, 2 HCl or 8 HCl rather. When 4 volumes of chlorine are reacting, it is giving 8 liters of HCl. So the resulting mixture (8 liters of HCl) and the unreacted hydrogen, only 4 liters of hydrogen have reacted, and total hydrogen was 6 liters. So how much of hydrogen is left? 2 liters. Unreacted, 8 plus unreacted, hydrogen. 6 minus 4, that is equal to 2 liters. So the answer is 8 liters of HCl and 2 liters of unreacted hydrogen. Four liters were already used up by the 4 liters of chlorine to form 8 liters of HCl. And how much was left then? 6 minus 4, that is 2 liters of HCl. Product was 8 liters of HCl and 2 liters of hydrogen was left as unreacted. Let's come to the next question. What volume of propane is burnt for every 500 cm cube of air used in the reaction? The reactions will always be given to you. You just have to check whether it is balanced or not. In the next reaction, propane burns in. Now it's given propane burns it. What volume of propane is burnt for every 500 cm cube of air? Now air doesn't contain completely only oxygen, sorry. So what is the percentage of oxygen in air? It is 1/5. 20% of air is oxygen or 1/5 of air. So amount of oxygen first you have to find out. First write down the C3H8 plus, this is question number 2, 5H2 for 5O2 will give 3CO2, 4H2O. First check the reaction is balanced or not. Then we find the ratio. 1 volume is reacting with 5 volumes of oxygen, producing 3 volumes of carbon dioxide. When the reaction is cooled, the reaction is cooled. So if not mentioned H2O as a vapor, water vapor, then we'll leave it, just 3CO2, it's not asked also. So first of all, we find out how much of oxygen is present in 500 cm cube of air. So 1/5 only is oxygen. So oxygen present in 500 is 1/5. You have to multiply 1/5 of air. So 500 total volume of air into 1/5, that is only 100 cm cube. 100 cm cube of oxygen. That means what amount of oxygen is reacting? Only 100 cm cube of oxygen is reacting. So now we'll write down 5 volumes are reacting with 1 volume. What is the question? What volume of propane is burnt? This is propane. So what volume of propane? 5 volumes of oxygen burns 1 volume of propane. Now just the unitary method. 5 volume of oxygen burns 1 volume of propane. So 1 volume of oxygen will burn 1/5 volume of propane, and how much? 100 cm cube of O2 burns 1/5 into 100. This is just simple unitary method. 20 cm cube. So what volume of propane is burnt for every 500 cm cube of air? Every 500 cm cube of air contains 100 cm cube of oxygen, and 5 volumes of oxygen burns 1 volume of propane. So 100 volumes of oxygen will burn 20 cm cube of propane.